students, welcome back to the second part of lecture number 20. So, we have been discussing about artificial neural networks, and I told you how the human brain functions in a very brief. Although we do not understand exactly how human brain functions, but we understand that this is a parallel processing system and main unit here is a neuron. We have tens of billions of neurons, and neuron has three important parts: dendrites which takes the input, and then you have a cell body which processes the input, and finally the axon body attached to the cell body is basically provide the output, and the output is fed to the next set of neurons by using synaptic links. So, basically what does it tells you? Neuron receive the input from other neurons, and that is why the inputs are combined. They are not like that I take input and do a regression. It is not like that, right? Here you are receiving an input neuron, and then it receives the input from another neuron which must have processed the data already. So, therefore, inputs are combined. So, once the inputs exceed a critical level, neuron discharge a spike, is nothing but electrical pulse that travels from the body down to the axon, and that is what is called the next neuron. Okay. So, once it exceeds a certain critical level, then only, and axon endings almost touch the dendrites or the cell body of the next neuron. It does not touch actually, it connects using a synaptic attachment. The transmission of any electrical signal from one neuron to other one is affected by these synapses which are connecting this axon of the neuron with the dendrites of the other next neuron. What does it tells you? That you also have dendrites here, okay, dendrites connected to the synapses, and then this is the body cell, okay, with a nucleus, and then you have a axon again. So, these synaptic synapses are taking information from giving the information to this dendrites of the next cell. Okay, that is what is called a parallel processing. So, now that is what. So, neurotransmitters are channels or chemicals which can be released from first neuron which binds to second neuron. That is how actually typical processing elements works. So, now how we can develop ANN based on this. So, you have seen that this is what is shown here. You have dendrites, and then you have a soma in which you have a nucleus, and then you have a axon. After axon you have basically synapses. So, that means these are my interconnects. So, therefore, these are my input variables. For each input variable I can put weights. So, I can put weights, I can linearly combine them or non-linearly combine them, that is my job. Like I can use W0 x0 plus W1 x1 go on plus Wn xn, or I can non-linearly combine them, W0 x1 square, W0 x0 square, W0 x1 square till Wn x1 square, or any other kind of thing, logarithmic also, any other functions I can use. Okay. So, now once this is done, then this is transformed to by a function, and this functions, these are what is written here. You can see y, this is an output, intermediate output of this network. Y0 is W0 x0, this is a linear, y1 is W1 x1 and yn is Wn xn. These are then summed up, and then these summed up things are fed to an activation function. So, let us go back to the board and tell you the 4 different steps. So, basically basic model of neural network is basically considered a series of functional transformations. Like I have what I have basically x1 x0, but let me write down that these are my inputs x0, x1, x2 to xn, right. These are my inputs, and I put weights. Remember, in weights are also used in terms of regression, right. So, these weights are placed there. So, then I can actually linearly combine them or non-linearly combine them. That is something we should know. You can always linearly combine them or non-linearly combine them, that is your choice. It is not your choice, means that depends on the problem. Okay. So, what I do is I write the function like this: Aij is nothing but I goes 0 to d, okay, and then W I j x I plus w j 0 1. That is the problem actually. Okay, now let me explain this. So, what we have done? We are linearly combining this and summing it up, right? This are linearly combined. So, this gives me x 0 w 0, x 1 w 1, x 2 w 2, x n w n, right. So, these are linearly combined, added, correct. So, now this is what is done in the first layer. Remember, this is the first layer. Okay, I can have many layers possible, right. As I said, it is a parallel processing system, you can have many layers. First layer, then I combine, then I do all the processing, then these are fed to the second layer, just like in a actual neural network. Okay, the data processed by the nucleus of the somatic cell is transmitted to the axon to the next cell via somatic the synaptic lapses, right. Same thing is done here. So, let me explain what is what. Here J goes from 1 to M or N, M let us write down. So, it is 1, 2 goes to M. These are, and the superscript 1 indicates the parameters in the first layer. Okay, you can have many layers possible, right, like in a synaptic lapses. So, the first layer, and this W are weights W I J. So, you must be thinking why I J, that is because I can vary J also, I can vary I also, right, depending on that, that is why. And this W 0, these are nothing but biases to the weights, remember. Okay, you can add biases to plus or minus depending on your need. And so, therefore, this A I J are actually activation functions, actually they are called activation functions. Now, I have done the activation functions, linearly combined them nicely, correct, and I varies from 0 to D and J varies from 1 to M, I sum it over, correct, I get the linear combinations of that. What do I do with that? So, this activation functions or activators actually they are transformed using differentiable nonlinear functions. Okay. What is that? Differential nonlinear function, okay. This is nothing but J is equal to H A J. This H is a nonlinear activation functions, okay. These are activators, which is nothing but addition of these things with some biases, right, that you must have understood, right. Now, this one is transformed using differentiable activation function H. This function can be used to different things. You can use sinusoidal functions, logarithmic functions, or any other function you want, okay, depending on the type of data or type of problem you are handling. So, this is what is transformed. So, that is what is the neuron cell does. Okay. Once the neuron cell collects all the data, then it has to process. The processing is done by activation functions, correct. So, once you process these activation functions, what do you do? You then combine these activation functions to provide output. Okay. These are linearly combined again, okay. That is why this gives you the output. Okay. Am I clear? And for that, let us write the output as A, capital A, not small a, capital A I, that is the output, and then I goes from 1 to M, because you are using M as a values of number of the neural networks. Okay. So, this is better use M actually. Now, this is D should be, because D is what is you are using, this should be D, otherwise it will confused. So, M is basically nothing but how many combinations you are doing. So, this is W Wij, right? Yes, no, Wik 2 second layer, and this is Ji plus W0 K 2. You can see that this are linearly combined. After you transform that, linearly combined, and K here, K can vary 1 to n, 1 to K, sorry, not n, correct. This can be worked out, what is exact value of K, what is exact value of M, but you have to understand the steps. So, they are linear combined to go to the second layer, and this process goes on. So, first layer, second layer, third layer, you can have hundreds of hidden layers, okay, which you cannot see that actually, and then finally, outputs are transformed to provide a set of outputs. Okay. These are actually transformed, all this information are transformed again and again, and finally, to provide an output. These are the 4 different steps which are used in artificial neural network. Okay. That is something which is very important for you to understand very clearly, otherwise you will forget. That is what I thought I should write it down and provide you. So, any basic neural network model use that concepts. So, please keep in mind these aspects. So, let me explain you again one more time. So, basic model consists of series of functional transformations. So, what do you do? I have input variables. Let me write down, these are my inputs. Input variables, I put some weights, combine them linearly, and then add some biases and sum it over. That is how I get a first functional transformation, correct. And once this is done, these Aij's are then transformed using differentiable nonlinear activation functions. Okay. We can also, because you have already done linear additions linearly by putting these weights, you do not do again linear transformations. So, you have to do differentiable nonlinear transformation. Why it is differentiable? Because then only you can find out the errors, otherwise you can't find out the errors. Okay. And this is then linearly combined, all these things. For remember, we are doing this for each neuron. So, that has to be linearly combined, and then to obtain this output which is unit output, activation output. Okay. And then this is basically then finally transformed to provide the output to the system. That is what is done. And so, if I go back here, that is what is this. Let us say a single neuron. Okay. These are my inputs x1 to x5, you see, these are my inputs, and these are my weights w1 to w5. They are sum it over, and then once it sum over, there is a transfer function. That transfer function is this. There is a transfer function here, or activation functions. And once this transfer function is done, what you are getting is a output from a single unit. So, that has to be then linearly combined. Many of these output has to be linearly combined, because you are getting output from each of these units, and then it has to be linearly combined. Once they linearly combined, you get AI, and then summation of that is used as output. That is what is the network works. Okay. Let us talk about it a little bit more. So, inputs are this x1, x2, xtem, and we are summing it over. You can sum it over like this way also, but we do not sum it over like that way. We basically put this weights, right. Always we put the weight. Remember, go back here, we do not sum it over like this. Why do you put weights? Because we do not know which variable is affecting the output strongly and which variable is affecting the output weakly. So, that is the major problem. That is why you have to put weights, and this is done in regression also. So, please go back my regression part of the lecture there also. So, that is why these W's are used, and these W's are basically combined, that gives you one output. Then how this is processed? Remember, this is processed by this function Zj, and that is what is processed by a function called H, and that gives you some output. Okay, that is called activation functions, and that is what is called as a transfer function here, or activation functions here. Okay. So, once it is there done, what do you do? Then basically you combine them linearly to obtain the output from this set of neurons, and that is then again transformed to provide the final output. So, you see here, that is what it is: input, weights, activation functions, and then you get outputs. Finally, they sum it over to provide you FU. FU is basically your step number 3. FU is step number 3, and step number 4 is this is step number 4, this is your step number 3, this is your step number 2, okay, and this is step number 1. That is what it is. So, that this is very important. The important aspect is activation functions, important action of these function which is used linearly combined. These are the aspects which you need to understand. So, I hope I have given you a very clear idea how a neural network functions. Now, we have to also talk about a little bit in the next lecture how this concept of perceptron came into picture. Okay. This is simple neural network, but perceptrons can actually change the neural network, what is called multilayer perception networks, which we will talk about it. Remember, neural networks basically takes you sigmoidal nonlinearity in the hidden layers, but perception can use step functions. So, how it can be used step functions, that we have to discuss in the next lecture. What I request is to read this different textbooks to understand the neural networks, and the last thing you have to do is basically error, correct. You have to understand we have to use error function, and here using error function is not very easy, and one has to use a clear concept of error functions, otherwise you may make a lot of errors. So, what kind of error functions you will use, how error functions for the neural network can affect analyzing error, and how we can use back propagation. We can use this error to send it back and correct weights, which weights are better, which weights are not better, we can always find out that. So, we will discuss all this in the next lecture, and then finally, we will talk about some KNN and all these things. We will basically finally wind up the supervised learning methods in the next lecture, lecture number 21, and then we move to the unsupervised learning techniques from lecture number 22. So, let me thank you, but I request you to read these materials little carefully and get back to me if you do not understand these concepts clearly. Thank you.